Hello students, welcome to the class. In today's class, I will continue from the last lecture. The question number 19 is, how many electrons should be removed from a coin of mass 1.6 gram so that it may just float in an electric field of intensity 10 to the power 9 Newton per coulomb, and the direction of the electric field is directed upward. Okay, so the question is, if a coin is here and you want this coin to float in an electric field of intensity 10 to the power 9 Newton per coulomb, and the electric field is directed upward, then you have to find how many electrons should be removed from that coin. The concept is, if you remove electron from that coin, then the coin will acquire positive charge. If you remove n number of electrons from the coin, then the coin will be positively charged and the charge on the coin will be positive Ne. And due to that positive charge on the coin will experience a force equal to the charge on the coin times the strength of the electric field. If the electric field is E and the charge on that coin is plus Q, which is equal to plus Ney, because n number of electrons are removed from that coin, then it will experience a force equal to Ne times E, because Q times E is the force experienced by the positive charge along the direction of the electric field, and the weight of the coin will be in this direction, and the weight is given as 1.6 gram. But see, when n number of electrons are removed from the coin, then the weight will not be 1.6 gram, it will be 1.6 gram minus total number of electrons into mass of electrons. But see, mass of electrons is 9.1 10 to the power minus 13 kg, which is very much less than the one mass 1.6 gram. So we can neglect the mass of electron, and I can simply write the weight as 1.6 g. This is not 1.6 gram. If I convert it to kg, then it will be 10 to the power minus 3. Then I can write it 1.6 into 10 to the power minus 3. This is in kg times g. G is acceleration due to gravity. Then if these two forces counterbalance, if F and W are equal, then this coin will float in the electric field. Therefore, that is Ne times E should be equal to 1.6 into 10 to the power minus 3, and G is 9.8. So number of electrons removed is 1.6 10 to the power minus 3, 9.8, and divided by E and capital E. E is charge of an electron, 1.6 10 to the power minus 19 times strength of electric field 10 to the power 9. So it will be 10 to the power 9, 10 to the power minus 19 is 10 to the power minus 10. So if it goes above, then it will be 10 to the power 10, and this is minus 3. So 10 minus 3 is 7, and 1.6 cancel. So it will be 9.8 into 10 to the power 7. So this many electrons should be removed from the coin if you wish the coin to float inside this electric field. Okay, let's move to the next question. Number 20 is, an electron is liberated from the lower of the two large parallel metal plates separated by a distance of 20 mm. The upper plate has a potential of 2400 volt relative to the lower plate. Then how long does the electron take to reach the upper plate? So the question is, if there are two parallel metal plates separated by a distance of 20 mm, and the upper plate is at potential 2400 volt relative to the lower end, then if an electron is liberated from here, from the bottom plate, then how much time it will take to reach to the upper plate? Now, why this electron will reach the upper plate? Because the upper plate is at potential 2400 relative to the lower plate. So due to that potential difference, an electric field will act in this direction. there will be an electric field, and due to that electric field, this electron will be attracted towards the upper plane, because you know the negative charges experience force in a direction opposite to the direction of electric field, and this electric field will be nothing but B by D. What is B here? 2400 volt, and D is 20 mm. 20 mm, if you convert it to meter, then it will be 20 to 10 to the power minus 3. Okay. Now, if this is electric field, then due to this electric field, this electron will experience a force in a direction opposite to the direction of electric field, that is towards the upper plane, and this force experience will be given by E times capital E. And what is E? E is 1.6 10 to the power minus 19 coulomb, and it is 2400 divided by 20 into 10 to the power minus 3. Okay. Now, due to that force, there will be acceleration of this electron along the upward direction, and this acceleration is nothing but F by m. And what is F? F is this thing. Let me write the expression EE divided by m. Now, it is accelerating in upward direction with an acceleration EE by m, and its initial velocity was 0. So I can use that formula S equal to ut plus half at square, where ut equal to 0, u equal to 0. Since u equal to 0, so the expression is at square. Now, what is S? This is the distance between these two plates. This is nothing but d. So d equal to half at square. From here, you can find the time taken by the electron to reach from the bottom to top. That will be 2d and divided by a and under root. So it will be t equal to 2 times d divided by a. What is a? A equal to E by m. E by m. Or I can write t equal to under root 2d. E is okay. What is capital E? Capital E is b by d. So it is b by d and divided by m. Right? Because E equal to, you see, b by d. So E was there and m is here. So now dd cancel. It will be 2 times m, 2, and if m goes above, it is m, and divided by, this is nothing but E into b, right? Because dd cancel. So it will be 2 times, and you see, m by E is nothing but 1 by E by m, because E by m is given. So m by E will be 1 by 1.8 10 to the power 11 coulomb per kg. And what is B? B is 2400 volt. Okay, I should not write volt here. This is 2400. If you solve it, then you will find this is something 1.6 10 to the power minus 9 second, or 1.6 nanosecond. I am not sure. You just do the calculation. I think it is 1.6 or somewhat. If you do the calculation, you will find it. So this is the answer. Okay. Okay. Let's move to the next question. Okay. So the question number 21 is: a simple pendulum consists of a small sphere of mass m suspended by a thread of length L. The sphere carries a positive charge Q. The pendulum is placed in a uniform electric field of strength E directed vertically upwards. Then with what period will the pendulum oscillate if the electrostatic force acting on the sphere is less than the gravitational force? And assume oscillation to be small. So you know, for a simple pendulum which has bob of mass m and thread of length L, the time period for small oscillation we know is twice pi under root L by G. But here the thing is, this bob of mass m now carries a charge plus Q, and it is in the electric field which is directed vertically upward, and the strength of the field is E. Now due to that electric field, the charged bob or the sphere will now experience a force, and the force will be directed upward in upward direction, and so the resultant weight, you can say the resultant weight now will not be mg, it will be mg minus the force acting vertically in upward direction. It is nothing but, we know, this is q times e. This is q times e. Why I am writing mg minus qe? Because the electrostatic force has strength less than the strength of gravitational force on that sphere m of mass m. So now what will be now g dash? G dash means, see, if there was no electrostatic force, if there was no electric field, then the mass will be attracted towards the center of the earth with a force mg. That is it. Its weight was mg, and so the in the expression we will write 2 by under root L by G. Now this G is not G. Now it is modified. Why it is modified? It is modified because it is experiencing a force in upward direction. So its weight will not be mg. Its weight will be something mg dash. And what will be the g dash? This g dash will be mg minus qe, the force with which it is now attracted towards the center of the earth, divided by its mass. It will be g minus qe by m. So now this t dash means, initially if it was t, when there was no electric field, if it was t, now after imposing electric field, its time period changes and it will be 2 by under root L by g dash, and g dash is g minus qe by m. So this is the new time period. Okay, that's it for today. We'll meet you in the next class.